Good morning, everyone. Today is the second and the last day of ICER. I am Zhang, a faculty member of the Department of Education in Seoul National University. We have a keynote speaker session, and before the keynote speaker session, I have two announcements. First, during the keynote speech, the interpretation service will be provided. If you see the Zoom webinar, you can see in the right corner, bottom of the right corner of the Zoom webinar, you can see the interpretation button. So if you click the button, then you can choose the language that you prefer. Second, you can join and listen the keynote speaker speech via Gather Town. Please enter the ICER schedule page, and you can see the button to enter Gather Towns. Okay, so today our keynote speaker is Byoung Zhang. He is the postco chair professor of Computer Science and Engineering, Seoul National University, and the director of the SNU Artificial Intelligence Institute. He has served as president of the Korean Society for Artificial Intelligence and of the Korean Society for Cognitive Science. Also, he has been visiting professor at BMBF Excellence Centers for Cognitive Technology Systems and Cognitive Intellection Technology, and Samsung Advanced Institution of Technology and MIT Computer Science and Artificial Intelligence Laboratory. He is a renowned scholar who has made countless publications in brain-inspired computational intelligence techniques, such as biointelligence by using mathematical modeling, computer simulations, and cognitive experiences to build models of cognitive information processing at molecular, neural, and whole brain scale. Today, he is going to give us a speech on how AI will shape future education. We are much honored to have you here. Please give him a big round of applause.
Good morning. Do you hear me? I hope. Yeah. So good morning. I'm Byoung Zhang from Seoul National University. I'm a current director of the AI Institute at Seoul National University. My topic will be at the joint point interface of AI and education. I'm not an expert in education, but actually I'm educating machines, not the humans. That's the field of machine learning in AI. But I will try to talk a little bit about how the AI will influence the educational future. So first, let's see some examples of recent developments in AI. Here is one example by Google, and let's see.
So what you're going to hear is the Google Assistant actually calling a real salon to schedule the appointment for you. Let's listen.
So how can I help you? Hi, I'm calling to book a woman's haircut for a client. I'm looking for something on May 3rd. Sure, give me 1 second.
So on the left-hand side, there's AI assistant talking to humans in the phone.
And 12 p.m.
And the AI calls the salon, hair salon, and make a reservation.
Just a woman's haircut for now? Okay, we have a 10 o'clock. 10 a.m. is fine.
Okay. That was the language capability of AI. Recognize the speech, human speech, voice, and understand the language and generate the language, even dialogues. The next example is about the vision, the machine vision. This is an example by Amazon. Amazon, you will see.
4 years ago, we started to wonder, what would shopping look like if you could walk into a store, grab what you want, and just go? What if we could weave the most advanced machine learning, computer vision, and AI into the very fabric of a store, so you never have to wait in line? No lines, no checkouts, no registers. Welcome to Amazon Go. Use the Amazon Go app to enter. Then put away your phone and start shopping.
So AI recognized all the
Take whatever you
items
like.
the customers are picking up
automatically added
and
to your virtual
automatically
cart.
check
If you
it.
change your mind about that cupcake, just put it back. Our technology will update your virtual cart automatically.
Okay, so there was about the human vision, like capability of AI. If we put them together and also in the put the AI in the real world, like a home environment, maybe we can have that kind of a system.
I am ready. Please open the door.
This is a RoboCop competition scene. In the home environment, the robots are moving around and get some missions by speech from the referee. And the robot should complete the mission, understand the mission first and complete the mission in the real environment. That means the agent, the AI should have the capability of a perception and action and even navigation.
안에 그런 거 없어. 완전 딱 포인트야. 익색 포인트를 가야 돼? 지금도 안 멈춰? 어떻게 하지? 타임아웃 일단 보자. 타임아웃.
This is the map of the robot, which is also learned by moving around in the environment. Okay. During the last decades, especially during the last 10 years, AI has made great progress, as we have seen. In the year of 2011, we have seen three interesting progresses. First, one was a Siri, Apple Siri assistant, talking to human and in speech, and then get some help or provide the help. And the IBM Watson was also announced in 2011. Interestingly, there was another one, big one, the Google self-driving car appeared on the road in 2011. So during the last 10 years, after that, we have seen AlphaGo in 2016. And now we see many smart speakers like Alexa and Echo. And more recently, OpenAI announced a large-scale deep learning AI platform called the GPT-3. And many companies are now trying to develop that kind of large-scale AI systems. So during the long, about 70 years of history of AI, maybe we can divide the AI history before machine learning age and after machine learning age. So modern AI is driven very much by machine learning technology, especially recently the deep learning technology. So learning is very different from programming approaches. Earlier, AI people tried to develop AI systems by programming, rule-based programming, the machine, meaning that we have a knowledge in some specific domain, and we formulate the knowledge in terms of rules and put that into the machine by programming. And that approach was relatively partially successful until 1990. But there was some limit in that approach because first, we don't know really what kind of knowledge we use, humans. And sometimes coding the knowledge into the machine is very difficult. The current machine learning approach is very different from the rule-based, knowledge-based approach, in the sense that the machine itself discovers and acquires the rules and knowledge automatically from data directly. So now we just provide the machine the huge data, and then the machine learner can automatically discover the knowledge and acquire the knowledge in its own form. In that sense, the machines can program itself. That's a huge change. So deep learning models are typical models now used for learning that kind of data. Here we see some specific deep learning convolutional neural network deep learning model. Deep learning means deep means many layers of neurons. So deep means many layers. So it's a brain-inspired learning model. So to recognize the human face, here the X, and then we like to distinguish it if the face is a man or a woman, then we label the data as a 1 or a 0. For example, man as a 1 and a woman 0. And then we collect a huge number of data, millions of human faces, and with their labels. Then the learning algorithm can automatically adjust the parameters in the deep learning neural network model here, and to learn which face or image is a man-like and which face image is like a woman-like. So basically what the deep learning is doing is mathematically relatively simple. It's just a function. Given X, it tries to compute Y using the F function. And there is a huge number of parameters, W here. And W is actually kind of a program, but this program is written by machine itself based on the learning data. That's the difference. All your AI approaches, humans try to code W in the rule-based systems, but here the W is generated automatically from the data by machine. So how it learns, basically it's a trial and error. Given input, it computes the output, and then there is a desired output. And in supervised learning, we give the solution, and then they compare, actually, the next slide, the compare, given the input, you compute the output, and there is a target output, and we compute the error, difference between target and the actual output, and then change the parameters, the synaptic weight. In the neural networks, the parameters are synaptic weights. They are changed, and that's the learning. And this is a simple mathematics, actually. We compute the parameter change and then correct the parameters so that next time the error is reduced. This is basically optimization process. Given input, compute the output, and correct the error. Again, given another data, it compute the output and change the error again. So in animation here, from input to output, from output to input by correcting the error, parameter change. And then, okay. This is called the error backpropagation algorithm, and actually discovered in 1986, about 35 years ago. And recent deep learning, even though deep learning is an extension of multi-layer perceptron, still uses basically this kind of algorithm. So there is another method of learning. It's called the unsupervised learning, where we don't provide the label, correct output in the data. The data consists of only the, for example, images, no labels. But this can also be considered as a supervised learning. If you think the target output is the same as the input. It's a basically identity function. Then usually you design the network in this way, reduce the number of neurons and then extend the number of neurons. Then we can get some low dimensional features in the original data. That's so unsupervised learning is doing basically compression, data compression. And by doing that, we can extract some underlying structures of the data. So where we can use this kind of technology, here we see an example.
NVIDIA has developed a new machine learning methodology for generating unique and realistic looking faces using GAN, that is Generative Adversarial Network. The GAN is not a new technology, but where NVIDIA differentiates is through the progressive training method it developed. The key idea is to grow both the generator and the discriminator progressively. Starting from a low resolution,
so here the machine is generating new faces from the learned model. So it learns unsupervised way, celebrity face images. And then this is a probabilistic model and can generate some samples from the model. So actually it generates fake images, unreal, realistic
new layers
human
that model
face.
increasingly fine details as training progresses. This both speeds the training up and greatly stabilizes it, allowing them to produce images of unprecedented quality. NVIDIA took a database of photographs of famous people and used that to train its system. By working together, the neural...
Okay.
NVIDIA.
So the last example of learning is we have seen supervised learning and unsupervised learning. Now the reinforcement learning. Reinforcement learning is a little bit different from the first two, in the sense that we are related here. It involves with a sequential decision making. So the sequence or the order of the examples are important here. So basically, it's a trial and error. The agent here does something first. It does something and then gets some reward feedback. And based on the feedback, next time it tries different things. And the objective function in reinforcement learning is to maximize the expected reward in the future. In the future is important. It tries to get a reward as much as possible in the future. So the task here is to walk longer distance. So it gets a reward if the agent here moved a long distance. The principle is the same, even though this creature has 4 legs, different from the 2 legs of a human agent. So basically it's a trial and error. Okay, and then, so there have been some technological breakthroughs in deep learning. I will show you some of them. So first is the image processing, vision, computer vision. So given 1.2 million image photos, and then the task is to classify 1,000 objects in this image. And this challenge was held from 2010, and from 2012, deep learning technology won the challenges afterwards. And that was one of the first breakthrough that showed the capability of deep learning models. And the same has happened, interestingly, similar way in speech recognition. Speech recognition has studied a long time in the history of AI. but deep learning made almost a breakthrough in improving the performance around 2012. As we all know, the AlphaGo also used the deep learning. And interestingly, the deep learning technology, AlphaGo had actually used all the AI technology, not just the deep learning. It also used the reinforcement learning in the framework of reinforcement learning. But deep learning made some improvement by evaluating the value function in the reinforcement learning. We need the policy function and the value function to really implement the reinforcement learning. AlphaGo used a deep learning model like image recognition for evaluating the value function. So this is the same as used as the image recognition. Just AlphaGo considered the Go board image as like a human face image. It recognized all the different patterns in the Go board and to predict which movement, which move will be the potentially best for winning the game. One breakthrough is actually came in machine translation. So this is the architecture used by the Google Translate. They called it the neural machine translation here. You see here the given English-Korean translation, for example, we just provide the learning data consisting of English and the corresponding Korean sentence. The X is English, for example, Y might be the Korean. And then the rest is done by the machine itself. Here is this layer by layer, it's called the recurrent neural net or LSTM, the modern version. And then just the translation architecture consists of neurons and layers of neurons connected recurrently each other. And there is no explicit rules here for understanding by humans. There are no linguistic rules here for humans, but the machine discovered actually in some way very complex translation rules in its own form. Unfortunately, humans cannot understand that. That's so complex. So many parameters are in the deep learning model. And that's maybe one problem for deep learning approach. The humans cannot understand what's going on there. It's so complex. But what it demonstrates is that the behavior, the X and Y, the predictive power is huge. A more recent research is going on, like vision and language combined together, even in the story. It's called the visual storytelling. So learning data consists of image and the corresponding text description. And here, 5 images and text in sequence. So when the machines learn these data, and then it's generally learning kind of visual stories. And once learned, we put the image, only the image into the model, then the machine can generate the corresponding sentences, kind of stories, linguistic stories. So if we collect a huge data, maybe the machine can really generate a human-like story. As I have mentioned already, the recent developments in deep learning, the OpenAI announced a huge scale of deep learning model consisting of 175 billion parameters, synapses. This is still, I think, much smaller than a human brain in the number of synapses, but it's a huge model. And they used 300 billion words in the literature to train the huge model. And the system generates sentences, kinds of writes articles like humans. So this is a hyperscale AI models. Most companies are now trying to build in Korea too. AI also is applied to science. So the DeepMind people who developed the AlphaGo also developed the AlphaFold program, AI program, to predict the 3D structure of the proteins. The protein structure prediction is important for kind of a drug discovery or drug development. So AI can be used, of course, in education in many different ways. I think already, for example, children use tablets, for example, to learn digital text or others. And we already can get many detailed data from their learning process. So AI can analyze and learn from that data. For example, which problems are difficult for that student and how much they are interested in which parts of the problem or aspects and so on. So AI basically can customize and personalize the education, provide a personalized education, maybe better than the teachers and even parents, technically, of course, but there can be some issues like ethical issues or privacy issues as well. And I have reviewed some papers for this talk on the using deep learning models and AI for educational area. One was in the lecture room, classroom, the camera can record the behavior of the students. For example, facial expression and head movement and so on. Then the deep neural net model can analyze the student behaviors. Also, the deep learning model can model not just the behavioral level, but cognitive levels of student behavior. And especially in online education, using some sensory data, cameras, mics, and the mouse, and the facial expression can also be recognized, and eye tracking can also be used. Eye trackers, also hand gestures can be used to analyze the students' interest and maybe the performance. So AI, as we have seen, can basically advance very much the linguistic capability and the visual capability, perception, and as well. That can be used for many kinds of personalization of the education or improving the performance at the behavior level as well as a cognitive level. So of course, many smart speakers are used for especially children for dialogue and question answering, and even in speech. They can recognize the speech and generate the speech as well. So some examples were that. And in the rest of time, I might provide some more broad view of AI going on in other industry sectors. So at home, we will recognize the AI. For example, the refrigerators, maybe in the future, will have cameras, and they can, the refrigerator itself can know which food is missing, and then can request, for example, to shop some specific food or and so on. Even the washing machine can have cameras. I'm sure they will. And then the washing course can be more intelligently, automatically controlled than now. And here you see some research going on also on cooking robots. Some companies are already working on kitchen robots. I will show you another video as well on the right. This is a Boston Dynamics Spot robot. By the way, Boston Dynamics was acquired by Hyundai Motors recently. So the Spot Mini moves around at home environment because they have legs, they can walk around. By the way, this motion is not fully automatic. Humans controlled the motion, the remote controlled partially at the time of videotaping. But recently they work on more autonomous navigation and manipulation. So the robot can move even in staircases. Okay, so that was at home. Of course, at hospital and healthcare, in healthcare, personalized healthcare, already AI is used even on the smartphone as well. Big change has been happened in finance. We now have some robo-advisors, kind of a chatbots, talking to humans in text to advise some wealth management, for example. Also, the investment companies use AI technology. Also, the credit decision-making is done partially by AI. So in finance, we already use AI technologies a lot. Even in factories, AI can help improve the decision-making and fast decision-making. The factories can have more sensors, and then all the sensory data can be analyzed and predicted in real time by AI to prevent some accidents or to improve the precision and accuracy. Big change has been happened recently in logistics and warehousing. Because of the corona, it was accelerated. So human shortage, labor shortage requires introduction of more robots. So more AI robots will be used in warehousing.
You are here on the booth at Universal Robots, the market leader for collaborative robots. We here at Universal Robots.
So the robots pick up the items and pack into the box or deliver the boxes. And the market is growing very fast in this area because many people order online and e-commerce without going physically to the shop. And in shopping or retail area, the Walmart already introduced the robot to manage the inventory. So the robot moves and scans the shelf to know what items are missing, and automatic inventory management. And also some hotels are introducing robots to make some services within the hotel. So if you call the reception to get some towel, for example, the robots will deliver.
Hello, your delivery has arrived.
And we have seen the Amazon Go, right? And as we know, the autonomous driving, self-driving cars are introduced in many different areas. Still some, I think the trial, for example, Google Waymo and Neuro and so on, other companies, there are many autonomous driving companies now. So as we have seen, everything is about data, because we have more data and more broader multimodal data now, and machine learning, deep learning especially, can be used to model the data and to predict the system and even recommend or prescribe some treatments. So it can be energy area or defense or security, and of course in education. Finally, there are some discussion points. AI, the capability of AI is increasing very fast, especially because of the computing power is increasing very fast. Also, the size of data is increasing very fast. Then the AI capability will automatically in some way increase. And at some point, it will excess the human intelligence. People say that's the singularity point or super intelligence. So in some specific area, we cannot avoid that. AI will excess the human capability, especially that AlphaGo has already actually demonstrated that in terms of AlphaGo gaming, machines can be much better than humans. So that's good. So AI provides efficiency and productivity and economy. But there are some issues to be careful. It's not always safe. It's not always fair. And sometimes we cannot trust the AI. And in many aspects, so we should be a little bit more careful about the safety, fairness, and trust. Because AI can be biased indirectly by data, for example. Current AI learns from data, and who provide the data, and depending on whom, the prediction results of AI might not be fair. Sometimes not very much trustworthy. So it's social and some legal issues as well. Another thing many people worry about is a job loss, job security for humans, because many AI technology replaces the human jobs. It should also be considered in policy making. So those are some social issues why people worry about the progress of AI. So in terms of technology, it's okay, but in terms of a social change, sometimes it can be a big issue. So that's why also AI people are working on AI ethics, how we provide the AI system some kind of ethics of a value, or how it influences a society in general. So that's other issues. But in the end, AI and humans should coexist, co-evolve, help each other, and live together in the real world as well as in virtual world. So maybe that's a good lesson that we should use AI for human purpose. So AI can be friends. I have listed some of the movies because they can help us to predict some future. Not really, but sometimes helpful. So AI can be friends, assistants, and also companions, but it can also be competitors for humans too, like job security issues. So we always have to consider them together. So last, during the 70 years of AI history, actually philosophically, in the first generation, we tried the rationalistic deductivist AI systems. They were very good at reasoning, but they were very poor at learning. And current learning approach is a kind of empiricist approach and inductive reasoning process, very much probabilistic and data-driven. But current machine learning approach is also missing some important points like cognitive capability. So in the future, new AI should consider more cognitive aspects of the system, and especially it should come from the closed world into the real world, open world. In the open world, everything is changing, dynamic, and so not easy to even learn. So that's the new challenge the AI community is facing. But people are working on that. Especially AI is now considered as a perception, action, and cognitive systems, not just some programming system, symbolic system, but it's more perceptual and the action systems in the real world. And we are at the current stage in this area. So with the deep learning, we have made a great progress, but we also need to go to the cognitive AI, and that may lead to us, lead us to human level AI. And the rest is there are some philosophical issues as well, like can machines have agency or free will or even consciousness? And that kind of discussions are very much philosophical. And but sometimes we may need to think of that because technological advancements may cause some social problems, ethical issues as well. So we need to think of that, but the technology-wise, it's still far from now. Okay, thank you very much.
Thank you, Professor Byoung Zhang. I would like to announce that this is the end of the keynote session. Morning sessions are available starting at 10:50, so please continue to participate. Thank you very much.